how we can improve it to make it more realistic. Okay, good afternoon, I guess. No time. Today, I'll try to simplify what is this research to make sure that everyone will get something out of it as a take-home message. Okay. Here we will be discussing what is the existing travel salesman problem, how they apply it, and how we can improve it. Let me get started. When we look at the outline, we have very few topics. First, we have an introduction of what is traveling salesman problem. Then we will look into the proposed approach because of the limitations. And we have a simple case study from North Cyprus. And then we have few conclusions and recommendations. All right. Here, the map that you see is actually the case study that I have from that one. If you look at the definition, we have a bunch of cities that we want to visit and come back to our origin location. And what is the shortest total distance or time that we can have by ordering these cities in a certain fashion? Okay, so that's a very simple explanation of the TSD. And of course, like many methodologies, we have an objective function here, and it is either minimizing the total travel distance or total travel time. And in order to do that, of course, we need distances between the pairs of the cities or origin and destination and between destinations. And that distances will form the distance matrix. The next step is to create combinations. So we have to try different ordering of the cities, the order of visit time. And that is factorial of the number of cities. So if we have 5 cities, then we are talking about 120 combinations. So do you think we can do it in a short time by hand? Maybe. But with computer, I'm going to show you we can do it in like 0.2 seconds or less than that, depending on how is our approach. And for each combination, we obtain the total distance, and we pick up the one that satisfies the objective function. Well, most of the time, if you look at the internet, if you search in Google or other search engines, you get the distance matrix representation that is direct distance. That means it's not like bird's flight, or I can talk about like crow's flight, which is very famous in Cyprus, especially in Pakistan. Okay, and the Euclidean distance is a direct distance, but Earth is a sphere, so there's a modification to it, other side. But is that enough? We are going to see it. Okay, and they do provide some advantages that I did mention here. It's fast. but is it accurate? Well, unfortunately, there are some issues if we deal within a city or in small places like Cyprus. We will have some errors in the distances because of the street network is not represented. So let's look at the proposed approach. In the proposed approach, we decide to use the existing road network and also have a automated data extraction in real time. Okay, and in order to do that, we decide to use OpenStreetMap. I don't know how many of you are familiar with OpenStreetMap. It is freely available. It's the largest volunteer supported system. And there's a tool, OSIO, open source routing machine. It's very fast. It is written in C++. So you can extract, you can request the distances by giving the pairs of the latitude and longitude values. And in order to contain everything in an algorithm, we use Python for that purpose. Now let's go and look at the case study. So here I assume that the union of the chamber of engineering chambers and the architects, let's say they have to visit and deliver a new building code to certain municipalities. And I picked up only 5 of them. Of course, we can solve it for 20 municipalities easily. It takes a little bit more time. So we have to visit Lefkoşa, Gaziantep, and come back to the union building in Çağlayan neighborhood. So here again, our objective function is to minimize the total travel time. And on the left-hand side, you see the coordinates. The first one is the union buildings coordinates. The other ones are the respective municipalities. And here we have the map of it. If you look at the direct distances, you are seeing a symmetric matrix. It is both directions are the same because we are measuring it as a direct distance, like a crow's flight. Okay, a bird is flying. So nothing is wrong with here. The values here are in meters. And if you use the OpenStreetMap with OSRM and make a request, we get a different set of values. And if you notice that this is not a symmetric matrix anymore, because some roads are one way and the round trip may not be happening on the same street. Okay. Well, after the analysis, we see a slightly different order of the cities. The one on the left-hand side is the direct distance. By using the direct distance matrix, we have L that is almost 49 kilometers shorter than the actual. We are just talking about only 5 places to visit, and we have such a big error. And before coming here, I checked this order values by looking at here, taking the values, and the first one, the one on this one, if we use the road network, it will be 42 meters longer. Only 42 meters, but the objective function is the minimum total distance. So that's why the other one is being selected. All right, let's go to the conclusions. Today we talk about the transportation engineer, but in civil engineering you can apply the same to many areas. Maybe in a factory or construction companies, they may benefit from it. So this is a very suitable tool for that purpose. And we propose to use the actual street network, which is more accurate. And as long as you have internet, you can in real time get the results immediately. If we reduce the total time, travel distance or time, the energy consumption and time consumption will be reduced. So that is an advantage if you think about many organizations, such as the logistic companies, use it. And we can apply it to the other disciplines. And of course, it's an open source, but there's no licensing fee. All right. Thank you.